Hello everyone, am I audible? Cool. Is the screen also visible now? Is the screen also visible, people? Cool, cool. So first of all, I think we guys are meeting after a long time. How is everyone doing? Yeah, I'm in Bangalore, Sankalp, in Bangalore at the moment. You guys remember me, right? Hmm. Right. Cool, 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 cool. Yeah. Cool. So we are going to start with high level. Yeah, I am happy to see you again, Arpit. Yeah, Harshal, Deepika, everybody. Happy to see you back, guys. Okay, cool. So we are now starting with high level design classes. Okay. How many people were there in the low level design classes? So I see 51 people in the class today at this point in time. Uh, was the number always around this only? Roughly how many people used to attend? Okay, 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 cool. Which is bad. Maybe I should drop an email to students so that they can start attending the classes now. Cool. So yeah, in the last few classes, in the low level design classes, you would have seen that how do you write the code of any big system, right? So how do you write a code which is modular? Okay, so let me just do it. Whenever you are designing a system, whenever you're designing a big system, there are two types of designs that you need to take care of. One is low level design and the other is high level design, right? Low level design may you need to actually take care of that your code that you're writing should be modular, should be extensible. That is what happens if a new functionality needs to be added. How can your code handle it and how beautifully your code can handle it, and then it should also be readable, right? So these are the things that you would have studied in your low level design classes. One, when it comes to high level design, the major point of focus is that how does your code handle scale? Okay, so what is meant by scale? Scale means that the high number of requests, high number of computational storage requests that are coming to your system. Okay, so how does your system handle scale is something that you would be concerned about while thinking from a high level design perspective. Okay, so what all small components would come into it? So let's say how to build a system which has huge number of concurrent users. Okay, and let's say, okay, so are you guys following what we are discussing? The basic difference between low level design and high level design? Cool. So in high level design you would have to answer questions like that: how many concurrent users do I have? Concurrent users basically means users who are accessing your system at the same time. Okay, then similarly how to handle those concurrent users, then what data needs to be stored and how would you store that data. Okay, what data needs to be stored and how would you store that data. So how basically would it be answered by, do I store my data as in a SQL DB? Do I store my data in a NoSQL DB? What are the things that I need to? Okay, so that actually brings me to the third point, that what are the design decisions that I need to make. The system that I'm designing, is it more worried about being available all the time? That is, my system should be up, the users can continuously get some data from my system. Should it be available? Should I be worried about the consistency of the system? Consistency basically means data consistency. By that I mean that is my system always returning the answer which is the latest answer. Okay, then we would have to talk about, as Harshal says, disaster recovery for sure. So what happens if some server, goes down, something goes bad? How do I ensure that my system as a whole is still working and can still come out of that disaster, recover from that disaster? Okay, then we would want to discuss about what is the turnaround time that I want to have my system. for my system. Okay. Turnaround time basically means that what is the amount of time that my system takes to return an answer to one request. Okay. Archit, you did not miss anything. We are just beginning the class. Okay. Then you need to take care about that. What is the QPS that your system needs to work at? What is the QPS? QPS is that how many queries per second can your system handle? Okay. Are these things making some sense, people? Do you have some idea of these questions? Have you seen these questions before sometime? Okay, cool. Right. So this is basically what we are going to discuss in several classes going forward. So let me give you a brief overview. Yeah, let me give you a brief overview of how the high level design classes are going to be structured. Today is our first class. We are going to discuss the basics of high level design. We are going to, let's say, discuss about CAP theorem. We are going to discuss about stateful systems, stateless systems. Then we are going to discuss about consistent hashing. So in the very first 101 class, Anshuman would have taught you about consistent hashing, but still we would want to revise that because that is a very, very important concept. And I would just take your guys' opinion as to how much time should we spend on it. If you guys are completely sure about consistent hashing, we can spend less time, else we are going to spend more time. Then going forward, we are going to discuss every component of our system design one by one. So, okay, my audio output is a bit low. Okay, is that the case for everybody? Are you guys not able to hear me properly? It's fine. Okay, but I can just maybe bring the mic a bit closer. Maybe if that will help you. Cool. Moez, I think it should be better to you as well now. Cool. Yeah. So in thereafter, we are going to take one component in each class for the next 2-3 classes. And then we are going, let's say in one class, we are going to discuss about caching. In one class, we're going to discuss about storage and so on and so forth. And then we are going to discuss so many systems. So we are going to discuss, let's say 7-8 systems that are around in the real world and see how would you go about designing them. Okay. So we would just look at a problem statement. We would just discuss that what are the requirements, how do we take the design decisions here, how do we actually construct the design, what are the options that we had, what happened if I chose this option over the other, and so on and so forth. So trust me, over the period of the next, let's say 1.5-2 weeks, you are going to enjoy these classes a lot. These classes are going to be conversational classes. I am going to say something, I am going to ask you something, you are going to come up with your ideas, and we are going to evaluate each and every idea as to what check boxes that idea checks and what things that idea lacks. Okay, so these are going to be very, very conversational classes. Today is the class which we are going to use to bootstrap, make sure that everybody is at the same level with respect to the basic concepts, and thereafter we are going to discuss so many different design questions. And I'm pretty sure that after this module of high level design classes, you would be very, very comfortable with high level design. And for any SD1, SD2 interview that you give in any of the companies, you would be really, really confident about how to go about designing these systems. Cool. So this is what I had to tell you about how the classes are going to look like. Now let's start from today's class. Okay. So let's look at how does any system from the outside looks like. Okay. So how does any system, what are the small components that are there in any system? The first component that is there is definitely the client. So it's the client that accesses your system, right? A client can be, let's say, browser can be a client. So let's say in a browser, I type google.com. So for google.com, if I'm typing that, the client happens to be the browser. Or you can say a mobile application can be a client that you are actually accessing through a mobile application. Or let's say a desktop app can be a client, and so on and so forth. So these are the clients, the very first component in any system. Now, whenever the client wants to reach to some system and give a request to any system, so let's say, how do we actually do? Let's say I want to, from my browser, go to google.com. So what do I have? I have the IP or the domain. I have the domain name with me. I can type www.google.com, but that domain name is not going to help me in routing. Domain name, I cannot actually go to any system just by the domain name, as Sankalp already has rightly pointed out, and most of you, almost all of you would know. We have something called as a DNS server. Are you guys aware of this? Should be covered in the first class, right? Cool. So what happens? Your client actually goes to the DNS server with the domain name. DNS is nothing just a map. DNS, looking at the domain name, is going to return one IP or a group of IPs. We are going to discuss this later, that why a group of IPs, and when a group of IPs. We are going to discuss that, and how does our client handle those group of IPs. But DNS is going to give you a IP or a group of IPs. Okay. And now your client has the IPs. Let's say it received 4 IPs after the DNS lookup. The client is going to use a waterfall model. What is a waterfall model? Waterfall model simply means that it is going to go to these IPs one by one. So let's say I received 4 IPs, IP1, IP2, IP3, and IP4. The client is first of all going to hit the IP1 that it received. If that IP is responding, I can establish a connection, I can get my responses, that's fine. I do not worry about the remaining 3 IPs. If this is something which is not responding, waterfall model simply means then I will check with IP2, and so on and so forth. Does that make sense, people? What is a waterfall model? Cool. So once I have those list of IPs, my client is going to try accessing the very first IP that it sees. Now, once I have the IP, in your, if you have already had your computer network classes, then you would have already discussed that how routing takes place in the internet. So every resource on the internet has an address. That address is called as IP, and using that IP you can just route through the network and reach that particular destination. So you will go using that IP to a box for which the IP of that box happens to be the IP that you just received, and here is where my system starts from. Okay, here is where my system starts from. This IP will happen to be the IP of the gateway box in my magic box. Okay, so what is a magic box? I am just calling the entire system for now my magic box. Okay, so some magic happens, a request is sent to that magic box, some magic happens in between, and then it will respond back to the client with a response. Does it make sense, people? This IP that I received from the DNS and the IP to which I'm making a request to happens to be the IP of the gateway box. Okay, there would be so many boxes probably in this magic box, and for the first contact that I establish, I will go to the IP of the gateway box. Cool. Now let me actually draw this magic box properly, so that now you appreciate that how this magic box works inside. Okay, from inside. So primarily the IP, the gateway IP that I'm telling you, is also called as a load balancer in the cases of a distributed system. How many of you have this definition of distributed systems clear in your mind? What is a distributed system? A system which consists of more than one box, right? And your computation is going to happen in a distributed fashion is called as a distributed system. Does it make sense, people? Does it make sense? So Anshuman in the very first class would have given you the example of Delicious. How many of you remember that? Sanket, I will repeat it. So how many of you remember the example of Delicious that Anshuman gave you? Okay, right. So Delicious was a bookmarking website, and initially it actually started with a single system. The entire website, all the computations, entire data storage was being handled by a single laptop. Okay, but then as the scale grows, as you want, that laptop is not going to handle, will not be able to handle large scale, right? Because a laptop has some limited memory, has some limited storage. It cannot go beyond a particular QPS, and it also cannot go beyond a particular data storage. Whenever you hit that problem, that is your system can now no longer work from a single machine, the scalability problem arises. There are two ways to scale your systems. One way is that you do a vertical scaling. That is, you make the single box, replace it with a bigger single box. Okay. So what is vertical scaling? That is, you simply keep on making the machine bulkier and bulkier. That is, you still have one single machine, but the machine has a lot more memory now, has a lot more storage now. Okay. The problem with vertical scaling is that you will continuously have to keep on changing your boxes, right? So today, if you're handling a request, let's say handling a load of, let's say, 10,000 users, you are forecasting that your 10,000 users are going to grow to 50,000 users in by the end of this month. You can buy a new machine. But then what happens if that 5 times growth is again happening over the next month? And this growth keeps on happening. If this growth keeps on happening, you cannot just keep on changing your machines every time you want to anticipate a growth in number of users or growth in number of requests. Okay? Because the cost associated with buying a bulkier machine rises exponentially. Okay? And that is not a sustainable mechanism. If vertical scaling is not sustainable, that is why we come to distributed systems, or we call that as horizontal scaling. Okay. So what I'm doing over the last 10-15 minutes, I'm just trying to revise all these concepts for you so that the concepts become crystal clear in your mind. Okay, cool. So if vertical scaling does not work, you actually move to horizontal scaling. Horizontal scaling as a concept says that, okay, if you're anticipating the growth in number of requests, let's not change the machines, instead add more machines. Okay, so we are not going to improve my machine, the quality of my machine, instead just add more and more machines to do the same job for me. Okay, so let's say I am handling some requests today, and I'm anticipating a 5 times growth or 10 times growth in the month or in a couple of weeks. What I would do, I would just buy more instances of these cheap hardware only and just add more machines, right? This is what is called as a vertical scaling. Okay. Are there any real life examples? Oh, sorry, this is horizontal scaling. Are there any real life examples of vertical scaling? Right. So, Moez, vertical scaling is something that used to happen entirely till 1980s. 80s, 85s में IBM used to keep on building bulkier and bulkier machines, and used to just assume that, okay, if the number of requests are going to improve, companies or users are going to require more and more bulkier machines. But the cost is a very, very difficult factor there. But still, even today, you would find several systems still using vertical scaling. And the reason for that primarily is something that has to do with CAP theorem. Okay. So just maybe hold on for a while till I discuss CAP theorem. Then we will discuss that why vertical scaling still makes sense in some scenarios. And we will maybe take a few examples of what scenarios in which vertical scaling makes sense. Okay. Cool. Now let's come back to horizontal scaling. In horizontal scaling, as I was adding more and more machines, the problem changes automatically. If you have one single machine, the problem is fairly simple. You want to make a HTTP call to that machine does some computation, uses the data stored in the same machine, and returns me the answer. But the moment you change from one machine to more than one machines, now a lot of new complexities are added. Does that make sense? The moment you convert a single machine to more than one machines, a lot of complexities are added. Now, your outside user cannot be expected to make different calls to different machines for different functionalities, right? The outside user should still get us feel as if he or she is talking to one machine. Does that make sense? But now, just because your system compromises of multiple machines, you need to take care of how the machines are going to interact with each other. What will be the control flow? How will I collect all the data, do all the computation, and give a single response to my user? And what happens for the cases of consistency? That the moment I have multiple machines, and the moment my computation is spread over machines, the moment my data is spread over machines, I need to ensure that my data remains consistent. How many of you guys are appreciating this? Right. Okay. And just because I'm teaching this batch after a long time, let me just remind you guys. So I'm just revising these things very, very quickly because I'm assuming that you guys know these things. If there is any doubt whatsoever, feel free to ask me. I always like a class which is asking questions and not keeping quiet. So ask questions, whatever questions you have. If you want me to speed up, let me know. If you want me to slow down, also let me know. Sanket says that load balancer part. I'm going to come to that load balancer. Okay. Okay. Can you quickly run through the DNS example once? Uh, okay. Okay. So Archit says, can you please slow down a bit? A little slow down. This is what you're meaning, Archit, right? Okay. So I can actually slow down a bit if you want to. Sure, I can. Uh, can you quickly run through the DNS example once? Okay. Moise, okay. I will do that. Let me actually have a poll. Let me actually have a poll which will help me to understand that how many of you remember the things covered in the first class and what is the speed that you guys want me to have this lecture in. Okay, just give me a minute. Let me just add a poll. Okay. Um, cool. So you guys would be seeing a poll now. Just quickly. Sorry. 83% of the class has voted. The remaining 17% don't want to vote. That's totally fine. 83% is a big voting percentage, especially especially in the world that we live. Cool. So yeah, let me end the poll, and this is what you guys selected. So 63% of you, are you guys able to see the screen? See the poll results? Yes. Cool. 63% of you say that the first class was long back, you don't recall much, and you would want me to cover everything. 22% say that yes, you can quickly skim through them. Nobody said that he or she is not fine with anything that we do. That's great. Cool. So the class, most of you do not remember much. So we will have to actually cover it a bit slowly and ensure that everything is covered. Can you, okay, screen is paused, okay. Just a minute, guys, I'm sharing the screen, maybe some issue with the internet connection. Yeah, the screen is back, right? Cool. Yeah. So, so we were discussing about horizontal scaling, and we realized the moment we have more than one machines, the complexity of the system increases manifold, and now we have to take care about a lot more questions than we had to take care before. Okay, cool. Now The moment these more than one machines are added, you now need a gateway. Okay, you now need a gateway. Why do you need a gateway? You need a gateway because for the outside users, they should feel as if they are interacting with a single machine, right? So you need a gateway. Does that make sense to everybody? You need a gateway now. Okay, that gateway will have some IP, and you will make requests to that IP. Now, this gateway in most scenarios also functions as a load balancer. So what is a load balancer? If the servers that are going to do the computations for you are more than one, then the gateway should know that which particular server do I actually send this particular request to. Do you guys appreciate it? Let's say these were the servers that were actually serving requests for me. Now you need somebody who will reroute these requests or route these requests to one of these servers. Does that make sense? So this gateway is no longer just a gateway, but it also becomes a load balancer, somebody who is going to balance the load across the app servers. Does that make sense? Yes, Abhishek. It can totally serve as a reverse proxy. Cool. So gateway, load balancer. Load balancer should be clear now. We will be now discussing later on. Okay. Sankalp, we can discuss that sometime later. Let's not do that right now. Okay. Cool. So we have discussed that. Now we have the IP of the load balancer. So let me actually now keep on drawing the further aspects of the magic box. So you have that IP of the load balancer. You have now some app servers. Okay, these are called as application servers. Servers where the computation is going to happen. Okay, this is the app server layer. Then you have another layer which happens to be the storage layer. So these are going to be boxes which are going to just store your data. Okay, these are going to be, let's assume, hard disks. These are going to be boxes just to store your data. Does that make sense, people? So these are the layers that you have in any system. If you look it from the outside, you have a client. The client interacts with DNS. We will just cover what DNS is properly because Moez wanted me to cover that. I will do that. Then you go to the IP of the load balancer. The load balancer is then followed by a layer of application servers, and the application servers are then followed by a layer of storage servers. Does that make sense, people? Does that make sense? So your computation is going to happen in this layer, application layer. You can also store some data here. So these are boxes. They also have some hard disk memory with them, some secondary memory with them. You can store data there as well, but you can store data in a third layer as well, which happens to be the storage layer, whose only charter is to store data for you. Okay. Now you can also have some caches. Okay. What is the cache? A cache is a data that you store in sort of a main memory, which allows you quick retrieval and responding back. Do you know what caches are, people? Caches are primary memory storage locations where you store some data so as you can quickly access it, maybe without doing some computation. So the caches can actually come here as well. Cache can actually sit on the application server as well. And cache can actually sit between the application server and the storage layer as well. In fact, there is a cache beyond my system as well. So there can be a cache which sits next to the client, which is called as a CDN. We will discuss that also in the class when we discuss caches. Is this diagram clear to you folks? Is there anybody in the class to whom this diagram is not clear? I'm going to draw this diagram again and again throughout our course because this is what you design, like how you design any system. Okay, cool. So this is what your diagram looks like. Let me just, for some of your sakes, go with DNS once again. So the client usually has a domain name and not an IP. With using a domain name, you cannot route in the network. You cannot find the required location. So what you do, you go to a DNS server. DNS is nothing but a mapping. Okay, mapping between domain name and the IPs. Okay, IP or list of IPs. DNS will simply return you the domain name with the list of IPs, and now your client will just using the waterfall model use one of the IP and go try hitting it and see if it can establish a connection or not. Okay, now let me just discuss DNS a bit more. First of all, why do we have a list of IPs and not a single IP for some scenarios? For most of the websites, the DNS only has a single mapping, that is a single domain name to a single IP. But for some systems, for some domains, DNS actually has a list of IPs. So what kind of systems those are? So let's take Google for example. Google is a system or a service which is being used by so many everybody in the world, right? And a single IP means a single load balancer. How many of you appreciate that? A single IP means a single load balancer. A single load balancer in the case of a Google can not function with all the requests that Google is seeing, right? Those big systems can no longer do with a single load balancer. Okay? First of all, it's very important to understand that load balancer is a machine whose charter is very small. The functionality of load balancer is very small. It will just take a request and figure out using some logic that what box is going to serve that request and simply send that request to that box. Okay? So the charter of load balancer is very less. That is why a good machine, if you make a good machine a load balancer, it can actually handle a lot of requests. But even after that, for the systems like Google or Facebook, a single load balancer will not be sufficient because the number of requests that you're going to see are going to be so many. That is why in the DNS for those big systems, you actually have multiple IPs. Okay? So for let's say Google, you have let's say 10 IPs. Okay? So now whenever a client hits the DNS server and asks for the IPs of Google, the DNS server is going to return 10 IPs. Okay? The client will mostly first try with the first IP and see if that is reachable. Now a problem arises. Do you think if a DNS sends the same 10 IPs in the same order to everybody, is it going to solve my purpose? People, is it going to solve my purpose? It is not going to solve my purpose because everybody is going to hit to the very first IP, right? So what does DNS do? DNS actually shuffles those IPs, 10 IPs every time and sends a shuffled response to the consumer, to the client. And now the client will actually, just from the shuffled list, will just take the first one and see if that is reachable or not. Does that make sense? Now, DNS and also, okay, now the shuffling based on different routing mechanisms happens in the DNS server. Okay, so Harshal, what exactly do you mean? The shuffling based on the different routing mechanisms. So what is a routing mechanism here? We did not discuss any routing mechanism here, right? So in most, okay, so Harshal says round robin. DNS is a third party machine. Okay? DNS is not going to keep a track कि भाई Google के ये 10 servers हैं, मैं पहली बारी पहला server दूंगा, the next time I give the second server, the third time I give the third server. DNS is not going to keep that track. Okay? So any kind of complex mechanism, you cannot assume that to be there at the DNS. Okay? DNS is a third party thing. Google has requested requested an organization called as ICANN. ICANN is the organization which gives you IP, static IPs, and also maintains the list of entries that are present in a DNS server. So Google has requested ICANN to have 10 IPs across its domain name in the DNS servers. That's it. Now, whenever somebody hits the DNS server to inquire for the IPs of Google, you're going to get that 10 IPs, but in a shuffled order. That's it. So DNS has a very, very limited charter. Okay? There are some kind, you can configure a DNS in a different way as well. Now there are some DNSs which do not randomly give you the 10 IPs. Instead, they can actually look at the client's location, client's geo IP, and figure out which location the client is in and give you the IP of the load balancer that happens to be the closest to you. So those are called as geo location based DNSs, but that is just the added information that I gave you. You can just not worry about that as well. Does that make sense, people? Does that make sense? Okay. So there are some geolocation based DNSs as well. Cool. Now somebody is asking, can the DNS actually respond based on the loads that different load balancers have? No, totally no. DNS does not know the load. DNS is not Google's not my property. If I'm running a site, DNS is not my property. It has nothing to do with my load. I have requested it to have my IP. That's it. Cool. Now Sanket says, if first IP does not work, then will they hit the second IP and so on? Yes, Sanket. That is what the client will do. Okay. The client, when it receives the list of IPs, it will first try hitting the first IP. If that does not work, it will hit the second IP. That does not work, it will hit the third IP, and so on and so forth. Okay. 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 What is a local DNS server? Makes sense. So now there is a question of, nobody asked me that question, but let me first mention that question so that you guys appreciate the complexity. So how many websites do you think are there in the world? Okay, if that's difficult to estimate, let me ask a simple question. Do you think the mapping for all those websites can exist in a single system, single box, a single machine? No, it cannot, right? So DNS is something which is a hierarchical system. So you first go to the local DNS server that, let's say, your internet service provider has set up for your group of connections. Okay. So let's say you happen to live in a society in Model Town, and let's say for Airtel, they have a DNS server in Model Town. Now that's DNS server which will have the mappings of those websites which are very, very popular amongst the residents of those locations. Does that make sense? So all the websites that I am seeing a lot of time being requested, I will keep that in my local DNS, the mapping of those. But now let's say there is a person who is who is self-quarantined these days and has a lot of time in his or her hand, and now just tries every random website name and wants to see if that website exists. DNS can a single the local DNS can no longer be expected to have all the mappings, right? So what will it do? It will, if it sees a website request that it cannot resolve, it will go hierarchically up to a bigger DNS and ask if you have that IP for me, and so on and so forth. So this will happen in a hierarchical way. That is how you can actually assume that within a few hops, every website that exists in the world, you will be able to get a mapping for that. Does that make sense? Yeah. Sanket, it happens so fast because most of the websites, in fact, almost every website that you access, the mapping would be there in the local DNS. That is why it happens so fast. Does that make sense? Right. Okay. Okay. So Nikhil says, if a system is having more than one load balancers, ideally all the load balancers should be situated at different geolocations. So this is a question, Nikhil, that we are going to answer in the let's say next few classes. So don't worry, I'm going to discuss this in great detail. Yes, yes. So let's say if a new website comes up and that becomes very, very popular, you will actually bring that entry in your local DNS as well. So you can just assume it to be a cache which is based on most frequently used. Okay. So Deepika says, if few servers are down in the hierarchy, what will happen? So that is a question, Deepika, that we're going to answer in the classes going forward. That what happens if a server goes down? So that is a question that we are going to answer in greater details going forward. Okay, cool. Cool. Let's move ahead. Okay, let's move ahead. So we have now discussed that how does the thing looks like. So let's actually take one example. Let's actually take one example and take any random example and see how the data flows across this diagram. Okay. So let's take an example. So you guys give me any example, or do you want me to take Google's example, or do you want me to take some fancy example? So let's maybe take Google's example if you guys are not coming up with any fancy example. Okay, interview bit. Okay, so let's assume that you have interview bit is not a very good example in this case because the scale that we serve is not that huge, but okay, cool. Let's take maybe Netflix for example. Okay, so let maybe take Netflix for example. Okay, Netflix is something which deals a lot with CDNs, and I would want to avoid CDN at the moment. So let's not take Netflix. Let's actually take Amazon, for example. Okay, cool. Let's take Amazon, for example. So you are sitting and on your browser, you type amazon.com or you would actually type amazon.in. Okay. So now the client will actually go to the DNS and it will check the entry for amazon.in. There would be an IP associated or a group of IPs. It will just reshuffle those IPs and return back to the client. Now my browser knows the IPs for Amazon. Using the waterfall model, my browser is going to hit the first IP. So it hits the first IP. Assuming that that IP is up, it will hit one of the load balancers of Amazon. Okay? It will hit one of the load balancers of Amazon. And now what will happen? The load balancer now will do some magic. We will discuss what that magic is and will reroute you, will actually forward your request to one of these app servers. Okay. Now let's say your request goes to this app server, and this app server can also fetch some data from some storage boxes if it wants to. And we will also figure out how will it figure out which storage box to go to. Let's say it figures out that yes, I will have to go to this storage box. It will fetch some data, do some processing, and return something to the load balancer. The load balancer will return that to the client. And this is how the very first web page of amazon.com will be shown at the client's end or at your browser. Does it make sense, people? Mohini's question is IP and load balancer will have one-to-one mapping. Okay, right. So for the outside world, Mohini, yes, IP and load balancer will have one-to-one mapping. But actually, as you would agree, load balancer is a system. You have one IP, right? You have one IP. Let's say that box goes down. What you can do, you can just bring a new box, assign it the same IP, and have it there. So for the outside world, yes, it is a one-to-one mapping, IP and a box, load balancer, right? But for the inside, you can actually have a group of load balancers and so on and so forth. But that is something which we do not do primarily. We just take a single load balancer only, but we'll discuss that. Okay, cool. Now, this is a very, very broad way of doing it. Okay. If we go at one level deep, you would realize that there would be a lot of caches involved as well. So there would be some cache here. So let's say if you just hit amazon.in, you may not be actually required to go to one of the app servers, right? Because that is a thing that everybody sees, right? So maybe from a cache only, load balancer will fetch some data and directly return it to the client. Does it make sense? Now there can also be another cache, which is called as a content delivery network or a CDN. What is a CDN? CDN is a third party cache which happens to sit all across the world. Okay? So let's say amazon.in, whenever you hit the amazon.in and the web page loads, do you see a lot of images that you see every time? A lot of static images that you are seeing, your friend is seeing, everybody around in the world is seeing, right? So it makes no sense to fetch all that data from Amazon's servers. Does that make sense? Does it make any sense to fetch all those images every time anybody in the world hits amazon.in from Amazon's server? It does not make sense, right? So that is why you have a concept of content delivery networks, which is just a cache, but a third party cache, if you say so, which will actually have those those data or those images or those media files that everybody is seeing situated all across the world. So your load balancer will return the resources, but will return some CDN URLs. And so, okay, let's not go into greater details here because I'm going to discuss this in one of the further classes. So, but I hope you get some idea that the data can be fetched not only from Amazon, but also from CDNs. Do you get some idea, people? Cool. Cool. So this is how the control is flown. Okay, cool. Now let's, once this is done, Asfar, you are right. Cache can actually sit on the app server. Cache can sit before the app server. So cache you can have a global cache here as well, or maybe a cache can sit here as well. The cache can actually sit anywhere. A cache sits here as well for sure. A CDN sits between the client and the load balancer. Okay. Okay. Archit says, so frequently served pages are saved in CDN, you mean? So, Archit, the resources that are true for so many people in the world and which are heavy, you can store those resources at the CDN. This is what I meant. Mitush, are you asking what do I mean by saying static resources? So exactly the definition that I just gave. Resources that are constant or consistent for so many people in the world, and you want, and those are heavy, you would want to store them in the CDN so that you need not do that network call, big network call, and get that big data from Amazon all the time for every user. Cool. Let's now discuss a few more basic concepts. Different between each on app server and above cache. Okay, so Nikhil, are you asking the cache between okay, so Nikhil is saying what is the difference between having a cache on app server or not on app server? So that's the basic difference. Is if do you want your cache to be distributed or not? If you want your cache to be distributed, then you would maybe have a cache sitting on every app server. On the other hand, if you want to have a cache which is not distributed but a different, which is totally decoupled from the app server, then you can have a caching mechanism here which has all the cached data, and you need not actually couple it with the app server. Does it make sense, Nikhil? Even if it makes some sense, that would be fine because we are going to discuss this in the class in which we discuss caches. Cool. Now let me move to one more very basic concept, which is of static IP versus dynamic IP. How many of you know that? Do you guys remember what static IPs are, what dynamic IPs are? Okay, Archit does not remember that. Okay, so I will just very briefly tell you. Static IP is an IP which remains fixed throughout. Okay, so does my laptop has a static IP? No. So I am currently at my friend's place. So my IP at this point in time is a dynamic IP which the ISP of my friend has provided me for some time. How does that happen? There is a DHCP server that the ISP has set up. My laptop will request the DHCP server to get a dynamic IP. It will just give any random IP to me that it has, and can you draw? Okay, okay, sure. So what is a static IP versus a dynamic IP? Static IP is basically that the IP remains the same throughout. Okay, you have one IP that you have throughout. So let's say in case of InterviewBit, we have multiple lease lines. What is a lease line? Lease line is a dedicated line that the ISP has provided to us. Okay, that lease line has a dedicated static IP. Does that make sense, people? So static IP is an IP that remains same. That is yours. You own that IP. Okay. Versus dynamic IP. Just because not everybody in the world can afford to have a static IP, because what will happen? because not every system is in use all the times, right? And not everybody around the world requires a static IP. So why have a static IP for every single resource on the internet? That will not even be possible, because today there are billions and billions of devices on the internet. Okay? That is why the concept of dynamic IP comes. Dynamic IP is a concept in which you hit a DHCP server. Okay? The DHCP server gives you a dynamic IP for some time. Okay? So you now get a IP for some time, and primarily will not get you will not essentially get a unique IP in the world even at that point in time. Maybe that IP will be shared with some of the systems. Okay. What is DHCP? That is outside the scope of today's class. That is something which will come in the networking class. Have you guys gone through the computer networking classes? Yes. So was DHCP not covered there? It was covered, right? Was it covered? Not covered? Was covered. Cool. I hope it was covered, right, people? Hello. Yes, it was covered, right? So if it was covered, then you can okay, not very deeply. Okay, if that's the case, then maybe I will just go through the video and see if it was not covered properly. Then maybe we can maybe we DHCP is just a protocol. It's a dynamic क्या बोलते हैं इसका नाम क्या था? Dynamic host configuration protocol. Okay, so dynamic, this is what, as far as I remember, this is the full form, dynamic host. Can somebody just yeah, dynamic host configuration protocol. So it's just basically a protocol that will give you a dynamic IP for now. So dynamic IP is something which keeps on changing. So maybe you have one IP to right now, and you will have a different IP 30 minutes down the line, or the next time you connect to the internet. Okay, and that IP only remains with you for some time. That's it. Does it make sense, people? Cool. Now we know that difference. Now let's actually, okay, so in the case of DNS servers, the mapping should always have a static IP. Is that statement correct? You would not want to have a dynamic IP in the DNS servers, right? That should make sense. Cool. We have discussed what is the vertical scaling, what is the horizontal scaling. We have discussed what DNS is. We have discussed how any system from the outset looks like. Now let's actually, yes, Nikhil, yes. Okay. Yes, you basically, the lease lines is a very loosely used term, but yes, lease line basically means that you have a dedicated line for yourself, which has a static IP associated with it. Okay, cool. But lease line is a very loosely used term. So don't actually use that in an interview. But yes, this makes sense. Cool. Now let's actually discuss one more thing, which is very important and will be very important throughout this module. That is the difference between stateless and stateful applications. Okay. What is a stateless application? What is a stateful application? How many of you know that? How many of you know the difference between stateful and stateless? Okay, Aditi knows that. Nishant knows that, but most of you do not know that. Okay, cool. So, okay, let's take an example. Okay, let's say I am building a website which does this thing. It takes two numbers. It takes two numbers A and B and returns the sum of the two numbers. Okay, I am building this website. Okay, now you tell me, when I am building this and when I see a request which tells me you want to add A and B, do I require any other state to return this answer? Do I require any other information apart from what is there in the request to do this, solve this request? No. So these kind of systems are called as stateless systems. That is, you do not need to maintain any state. You can only consider the request that is coming and just respond back with the response. Okay, so these are called as stateless systems. Stateful systems, on the other hand, mean that apart from the request, you also require some other state that you have to give you the answer. So let me tell you, let me give you an example. So let's say that, let's take any example. So let's say you facebook.com. Okay, so you enter to facebook.com, and the moment somebody is sending, some user is sending the request that I want to see my timeline, do you think that's a stateful request or a stateless request? That is a stateful request, right? Because depending on which particular user is asking me for his or her timeline, the response that I'm going to give is going to change. Does that make sense, people? Only 3-4 replies. Does it not make sense to most of you? Okay, okay. So Archit says repeat. Archit, whenever you have a request for which everything that you need to give the response is present in the request itself, you do not need to consider any state, then you call it as a stateless system. That is, you can just worry about the request that is incoming and give a response. On the other hand, stateful is a system in which you maintain some states. You require some context. Ki, acha, this is the request, but I require some context that what has happened before. Okay, so let's say I want to see my Facebook news feed. So won't Facebook require the context that who am I? What have I done before? What did I like before? Who are my friends? Does that make sense? Okay, so Shikhar says, but that user is passed as a request. That's right. The user ID would be passed as a request. But just at looking at the user ID, can you actually do anything? No. You will actually have to hit your DB. You will actually have to check yourself. Ki what has that user ID done? Does that make sense, Shikhar? So that is what makes it a stateful request. That is, you have some state that needs to be maintained at your end to be able to serve to that request. Does it make sense to all of you now? Nikhil, you are right. Okay, Nikhil says, can we call it as a stateless? Yes, asynchronous is totally different from stateful. Do not confuse between synchronous, asynchronous, stateless, and stateful. Okay, that is a different concept. Stateful, stateless is a different concept. Okay, so now there is a question from Nikhil. When we submit a code to HackerRank, can we say that request as stateless request or app? You cannot call it a stateless request because that request is going to change the state that you have. So HackerRank will update ki acha, for this particular user, the state for this particular user changes, and now he or she has successfully or unsuccessfully solved this question as well, right? On the other hand, let's say I want to let's say okay, let me give you some more examples. Okay, no. Let me give you example of the companies that, yeah. So okay, Sukanya is absolutely right. Online calculators, right? So you just send in some numbers and you get some answer. They need not know who you are, what have you done before, and so on and so forth. So it can be totally stateless. Now let's take the example of Delicious. So Delicious is basically that you want to figure out that what are the bookmarks that I stored before. Would those requests be stateful or stateless? Those would be stateful, right? Because I need to actually store the state for that user. Okay. Now let's say, yes, Aditi, you are right. But the stateful versus stateless things are based on the applications that you are designing. So exactly. So let's say you just have a currency conversion website. You need not know anything beyond that. You just need to know the currency, which currency you want to convert from to which currency, and you want to know the conversion rate. That's it. So that will be a stateless application. Let me give you some examples of the company that I worked at. So I was at DirectEye, and my job was giving the most relevant advertisements for any web page. Okay. So there I built a system which was a categorization system, which will take as input a URL, and it will tell you that what is the category of that URL. Okay. So what does that mean? So let's say I will give you a URL which will be forbes.com/cricket/Virat Kohli scores his has completed 15,000 runs. Okay. Now that URL, if I'm giving to my system and my system is categorizing it as sports/cricket news, this is a stateless system. I do not require anything else but the URL that you're giving to me. I need not maintain any state at my end that how to reply to this kind of a query. So that is totally a stateless system. Does it make sense, people? On the other hand, let's say the other system that I built was basically about ranking the advertisements. So let's say there are some ads that so many people in the world are clicking. Okay? And now I want to rank the ads based on how the users are performing to those ads. That is going to be a stateful system, because to answer that, to rank those advertisements, I will actually have to fall back to the context that I have and tell you, okay, for this particular web page, this happens to be the ranking. How many of you appreciate it somewhat? Okay. So these are real world examples of what are stateless systems and what are stateful systems. Now let's come back to why this is important for us. Okay. So there are some questions. Let me try to answer those. Sorry. Asfar says, what if for categorization, I need to query about some past categorized data? Does it become stateful? Yes, it becomes stateful. If I need to store some state about that URL, if this URL comes, this is what I need to look at, it becomes stateful. Gives information about train number. Chauhan Prithvi, I did not get what you are saying. Do you want to unmute you, Chauhan Prithvi? Sukanya says, so to sum up, whenever the DB into the picture, those are stateful. Whichever does not require storage of information is stateless. Sukanya, that's a very loose statement to make, I would say. Whenever a DB is involved, that's not correct. The point is, whenever some state, some context that is required at your end to answer to a query, that is what a stateful system is. That is, you have maintained a state at your end, and you have to look at that state before you can reply. That is a stateful system. On the other hand, if you do not need to look at any data which is coupled with that request, then it becomes a stateless. So Kanya, does it make sense to you? Chauhan Prithvi, does it make sense to you? Uzair, that's right. Narayan Soni says for weather data. So let's say I am building an application. Let's say I am building an application which will just give me the present weather. Okay. So the request that I'm going to see is going to be, what is the weather at my city in Delhi? Let's say, what is the weather at Delhi? Now you guys tell me, what will I have to do? When somebody sends me a request, what is the weather at Delhi? I will have to reply back with the weather at Delhi. Does it make sense? So this kind of a system is something which is very difficult to categorize, but okay. So these stateful versus stateless is a concept, is a conceptual definition that you need to understand. Whenever somebody asks me the weather at Delhi, okay, I will actually have to check in my DB that what is the weather for Delhi, and I will have to respond that back. So yes, I am maintaining some state. Okay, I am maintaining some state to give you the answer. On the other hand, that state is not specific to the user that is sending that request, but yes, is specific to the request that is coming. So yes, you can call it as a stateful system. Okay. Aswar says, so if I'm giving, yeah, so yeah, you can call it as a stateful system because you are maintaining some state based on which you are responding. Okay. So Manish, that is basically the primary definition of stateless. So when the response remains the same, no matter how many times you call it, or no matter when you call it, that is primarily the stateless systems. Okay. So let's say if I make a request to a API today and I make a request to the same API 6 hours down the line, if the response does not change and it does not matter how many times I'm making that request, that you can call it as a totally stateless system. How many of you get that? Right. Cool. Okay, cool. Can we move ahead now? So we have discussed about stateless and stateful systems. Can we move ahead now? Cool. Now let's see, why does it matter a lot whether a system is stateless or stateful? So let's say you have this load balancer, and let's say you have some app servers that I told you, right? So there are some app servers. Now, if a system is stateless, does it really matter that if a request is coming and if my load balancer sends it to this server or this server? Does it really matter? No. In a case of a stateless system, it does not matter what particular app server is serving your request. Does it make sense? So in a case of a stateless system, it does not really matter which app server is serving your request because there is no state. On the other hand, when a system is stateful system means that you have maintained some state. So let's say I have maintained a state of, let's say I want to serve you the Facebook news feeds. So if let's say I am sending a request and saying, show me my news feed, and let's say I have divided my data across these app servers in this way that my data happens to be at this particular app server. Now, can this app server serve my request? Can this app server serve my request? No, right? So only this app server can serve my request. So when you have a mapping, a coupling between the servers and the data that you want to serve, and the requests are stateful, then the load balancer's job becomes very, very important, or it becomes very difficult. Does that make sense? The load balancer's job becomes slightly more difficult when you are actually actually designing a stateful system, because now you can only a particular server or a group of servers can only respond to that request and not everybody else. How many of you are clear with this? How many of you are clear with this? Okay, cool. So now Asfar says, what if all app servers are pointing to the same DB? Even stateful scenarios can be serviced by any app server in that case, right? That makes sense. So Aswar is saying, if every data is stored at the same time, at the same location, at a single storage DB, and there is no coupling between app servers and the data that you want to look at, then you can call it that yes, even a stateful application can be built without taking into account this new problem. But Aswar, let me be very frank, that is you will not be seeing that kind of a scenario anyway. Okay, because you're bound to see caches, you're bound to see so many different things. The computation maybe also would change at different app servers. So in maybe almost every stateful scenario, you would require a mechanism at the load balancer which can route you to the correct kind of a system and not to somebody else. Okay. Does it make sense to the person person who asked that. Aswar, does it make sense? Okay, so Aswar, do you want me to unmute you? Aswar, sure, sure. Let me unmute you. Hey, Aswar.
Hi, Tarun. My question is that, okay, let's consider a scenario that I want to query my phone balance. Okay, my application is based.
Query your phone balance.
Yes.
Okay.
So now, if I am sending the request to the balance inquiry API over a period of 6 hours, during which I have not done any changes in my balance. Okay, I've not made any calls. I have not done any kind of recharge. So then the response is independent of my request, right? But
No. Okay, okay. So now, so if you are going to say that this makes it a stateless system, that's totally wrong. The reason being that you have included a very, very big clause that if you have not made a call, right? So if you have not, if the system is, if a network is such that it will not allow you to make a call ever, and your balance remains the same, even then it is a stateful system, because still you will want to look at whose balance do you want to tell, right? On the other hand, if you, let's say, have yeah, so that's it. So the moment you have to look at your name and see that I want to look at Aswar's data, it becomes a stateful system, right?
okay. And can you please give me an example wherein, as you said that all the requests have to be serviced by a specific app server depending on the state.
Makes sense. Bilkul. So let's there are so many examples that you can actually draw. So let's maybe draw a simple example in which you are playing a chess game with a computer. Okay, so let's say you go to chess.com and you want to play a game with a computer, right?
Okay.
So you are, so this would be your client. You are at your browser, and now your client is going to make calls to a load balancer. Load balancer is going to make calls, going to forward every request that you send to one of these app servers. Now, let's say you started a game, right? You started a game, you made the first move. If you made the first move, the load balancer will actually record that move in one of your app servers, right? So there would be the logic of where the computer would be playing its moves and will be keeping a track of your entire game would actually be running in one of the app servers. Does it make sense?
So Tarun, this has more to do with session management, right? That if my session is broken from that app server, then my game goes for a toss, right?
Okay.
But if I'm talking about an application where session is not important, right?
Okay. Okay. So
Where I
first of all, we are on the same page that whenever you want to actually maintain a session, then
right.
you would want to want your load balancer to be a thing. Load balancer to have the capability of sending your request to the same app server all the time. Does that make sense?
That's right. That's right.
So,
Yes,
so,
that's
so a big chunk of examples where the session is maintained, you
yes.
would want to ensure that you would just see it's a stateful request, and you would want to ensure that every request goes to the same app server. That's a big chunk of example.
Yes.
Now let's say session is something which is not important, okay, but the user persistence is something which is important, right? So user persistence is important, which is just more generalizing a session and calling it a context now. Okay, so the context needs to be persistent. So let's now take an example of Facebook, right? So I want to check who all are my friends, let's say. So let's say there is an API which tells me who all are my friends. Okay, and let's say I can have 10,000 friends, and that API is not going to respond back with all the 10,000 requests at the same time. Instead, you can just keep on calling the next 10 bata do, next 10 bata do, next 20 bata do. Why I'm saying so? Why I'm designing an API which is going to be giving me friends in chunks and not all the friends at the same time? Point one, because that's more realistic. That is exactly how APIs are designed. You would want to paginate your data and get data one by one. Point two, it allows you to do a lot more things. What does it allows you to do? It allows you to involve caches into the picture, and allows you to have that leeway that, let's say, I added a new friend just now and that was not there in my cache. So the very first request that comes, maybe I can serve with the cache, and somewhere down the line it will be actually appended to the cache, and the next request will actually give me the newly added friends, and so on and so forth. But that's something which we're going to discuss in the next classes. So इस तरीके के केस में when you want to look at the friends that you have, you would want to actually, whenever the request comes, the load balancer would want to actually route your request to the app server, which is storing your data, right? And not to any app server. Why is that? Because if you can send your request to any app server, the problem would be that now either you will have to maintain all the data at all the app servers, which is a bad thing, which defeats the purpose of distributed systems, or you would have to have a single point of storage where the storage is not happening anywhere else but at a single point. That is again a very bad design, because just because you have lots of users and you want to and you want to divide your computation and you want to have a distributed system in place, your storage should also not be at a single point and should most likely be distributed. But even if your storage was not distributed, maybe at least your caches would have to be distributed. Maybe you would have a different cache here, a different cache here, a different cache here, and a different cache here. And if, let's say, you want to find the request friends that you have, let's say I want to send a request that tell me all the friends of us first, and let's say this is the box which in whose cache I had that data. So would you want me to route your request to this box? Of course not, because if you route me to this box and the cache does not have your entry, I will be forced to go to the single point, make one extra hop. It will increase the turnaround time, increase the network load, increase the load on the box, on the DB box, and would not be the best way to solve it, right? So whenever there is a stateful request, you would prefer that your request goes to a server which is designated to sort your requests out.
Okay, so the important part here is about the cache that is being maintained at the server level, right?
If you have a single DB, if you have a single DB instance.
Right. Okay. Also, just one last question. If I say that synchronous APIs and asynchronous APIs have something to do with an application being stateful or stateless, is it wrong? Are these two systems completely independent of each other?
Yes. So asynchronous and synchronous. So this is something that maybe we can discuss in the next class. That should not be confused at all with stateful and stateless. Stateful and stateless के लिए remember the definition that we discussed today, and do not confuse that with synchronous and asynchronous. Okay. When we actually discuss that, so most likely maybe in next class we will be discussing that. When we would be actually discussing about APIs as such. उस वक्त maybe we will discuss that, and then we can come back to this question and appreciate, and I would try to make you guys appreciate that more. Okay.
Thank you so much.
You're most welcome, Aswar. Okay, so just a quick question. So the discussion that I had with Aswar, was it making sense to all of you, or was it not helpful to you guys? Was it making sense? Right? It was. Good. That's great. Now let me see what are the other pending questions. So Lokesh, do you want me to unmute you? Lokesh, who wants me to unmute them? Lokesh, Kamal, Moez, anybody wants me to unmute them? Sorry. Okay. Can we move ahead? Cool. Let's move ahead. So now we just discussed that in the cases of stateful systems, the load balancer needs to have a mechanism which will allow it to figure which particular server do we want to route this request to. Is it clear to everybody? Is it clear to everybody? That stateful request के अंदर load balancer का एक छोटा सा काम और होगा. यार reply बहुत मुश्किल से कर रहे हो. ठीक है, cool. ठीक है, cool. Thank you. ठीक है. So that is clear. Now let's actually come back to stateless servers again. Stateless system है. उसके लिए let's actually see how load balancer can actually route your request. Okay. So let's assume it's a stateless system. So I am a load balancer. I happen to be a load balancer of a stateless system. There is no state. And now I want to actually send the request to one of the app servers. Now, what is my primary charter? My primary charter is that I would want to most likely reduce my turnaround time and ensure that the load is as equitably distributed as possible. Does it make sense? Does it make sense, people? Right. So one simple mechanism to do that would be round robin. How many of you appreciate that? What is round robin? That I will send the first request to this, second to this, third to this, fourth to this, fifth to this, and then sixth to this, seventh, eighth, and so on and so forth. Can somebody tell me what is round robin trying to maximize for? What is round robin trying to maximize for? Is it always guaranteeing you that the response time will be minimal or the turnaround time will be minimal? Is that a correct statement to make? No, that's not a correct statement to make. Kyunki, let's assume this happens to be a very old box. This box is very tired. This box is very old. It takes a lot of time to process a request. And if I am sending equal number of requests to this box and equal number of requests to the box which are very, very energetic and can process the request very quickly, then you are essentially for the calls that actually were unlucky enough to come to this box, you are essentially increasing their turnaround time. Does it make sense? So round robin does not optimize for turnaround time. Round robin would essentially optimize for the load at each box, or let's call it equal distribution of load at each box, right? That can be acceptable in some cases, can be unacceptable in some cases. Totally depends on the system that you are designing. That's it. What other options do we have? You have an option of least response time. What is that option? That option says that the load balancer is going to maintain what is the average response time for this box. Okay? And it will send requests to boxes based on their response times. Does it make sense? People, does it make sense? Cool. So there are different mechanisms, and these are very, very trivial mechanisms, very, very intuitive, and you can understand them. But there is one problem that maybe some of you would not be appreciating, and that is the problem of a box going down. Okay? Before coming to the point of a box going down, let me actually tell you one thing. Whenever you move from a single box to a group of boxes, whenever you do horizontal scaling, whenever you move to a distributed system, the probability of box going down is always there, right? Boxes will always go down. What do I mean by saying a box goes down? It can mean that the box went bad, or maybe the connection between the box and me went down, or maybe the connection was so overloaded that it was not responding in a fixed amount of time. So all these situations are bound to happen. So boxes go down all the time. Does it make sense, people? Sorry. So whenever you go to a distributed system, boxes going down is a thing that you should always have in your mind. In the next 15 minutes, I will be discussing about CAP theorem, and then I will appreciate for you guys that why that is a thing which is happening all the time, and why we always need to take care of that in distributed systems. Cool. Now, let's say if a box goes down here and the load balancer does not know about it. So what will happen? All the requests that I am by any mechanism sending to that box, let's say this box goes down, all the requests that I'm sending to this box, let's say by round robin or least response time, least connection, etc., etc., the problem would be that these requests are going to get dropped. Does it make sense? Because the box is not there. So we require a mechanism at the load balancer, even for a stateless system, that how to check which box is up or not. And Vijay is absolutely right. That thing is called as the heartbeat mechanism. What is a heartbeat mechanism? Heartbeat mechanism is a mechanism in which every box is going to send a heartbeat to the load balancer. What is heartbeat? It is just going to send a ping at a fixed duration of time and tell the box that, hey, I am alive. Hey, I am alive. I am alive. I am alive. Now, based on these pings, the load balancer will know that which box has not responded to me for the last, let's say, 60 seconds, 120 seconds, and can assume that this box, something is wrong with that box, and maybe this box has died. So let's say this box did not set the ping for, let's say, a timeout time of, let's say, 120 seconds. Now the load balancer will stop sending requests to this box. Does it make sense? Does it make sense, people? So these are called as push heartbeats. So every box is sending a push heartbeat, is telling the load balancer that, hey man, I'm still alive. You can just send a request to me, I will solve it. Okay? Then there is another mechanism which is called as pull heartbeats, which basically means that the load balancer itself inquires and asks, hey man, are you alive? And then the the box replies by saying yes. So that is also a way that you can ask question and get a response. That is called as push heartbeat. Does it make sense to all of you? Cool. Good. Now let's look at the question that Abhishek is asking. Abhishek is saying that you can have, okay, Rohit, I will come to that. right, I will come to that. So you can have, sorry, you can have a box, a master slave architecture. So let's look at what is a master slave architecture. We will be discussing this in more details, maybe in some other class, but just because somebody has asked that, so let me tell you what is a master slave architecture. So for every entity, so every box that I drew here, this is an entity. Does it make sense? Is an entity. Now for every entity, if you follow a master slave architecture, for every entity you will have a master box and you can have multiple slave boxes. Okay, so this is one entity, a master and some slaves. So what happens in a master slave architecture? That you are going to say that some jobs are assigned to the master and maybe some jobs can be assigned to the slaves. And so, okay, so so this in itself is just a master slave architecture. Whenever a master goes down, let's say this master dies, then the slaves amongst themselves are going to elect a new master, and one of them will cease to be a slave and become a new master. And when this box comes back, it will again become a slave. Does it make sense to you guys? What is a master slave architecture in as a concept? Now let me tell you that there are different ways to exploit this master slave concept. One single simple way is, let's say a master goes down, a box will always go down, right? Just because a master is down, you can still serve requests. How come? The slaves can elect a master amongst themselves and that master can start serving requests. Does it make sense, people? This is one utility. Another utility can be that you can very well distribute the read load. What does that mean? So there are some systems that I have seen which do this very effectively, which says that every write that is happening is going to be written at the master. So let's say a write request comes, it is going to be written at the master, and it's master responsibility to sync that write to the slaves. And whenever a read request comes, maybe the read request can be sorted by the slaves. Does that make sense? So let's say there is a system which is very read heavy. Okay, there is a system which is very read heavy. Maybe a single box is not going to be able to serve all the requests of reads. So a master cannot serve that. So why not have the slaves doing the reads for you? Does that make sense to people? Does that make sense to people? Nikhil, I am not claiming that master will never serve a read request. I am saying that one way to exploit this master slave architecture is to maybe have the slaves do the read. Okay? Master can still do the read, but you can design a system in which you can say, "Okay, yaar, I will write in master and read from slaves." Okay? Or you can have a system in which you can say, "I will write and read everything from master," and slave is just to ensure that the data is persistent. ठीक है? So now people are saying that what happens people are saying that the data may not be consistent. So that is something which we are going to discuss later. What is consistency and what happens if it is not consistent or not? We will discuss that later. Aswar asked, so then which system decides which read request goes to which slave server? Does the master act as a load balancer? That can totally, yeah. So Aswar, in that case, yes, a master will act as a load balancer, may act as a load balancer, or maybe the system above it will have the connections to every of them, to have the connections to the master and the slave, and the system above it can decide which slave will answer that, right? Because the point is, if the master acts as a load balancer, then essentially you are defeating the purpose of the slaves solving the read. Because if every read actually goes to the master, then maybe why not actually serve the read from the master itself? Does it make sense? Okay, Aswar. Yeah, sure, Aswar. That is a capability which will definitely be there, because so basically you are actually going to expose APIs, right? There is going to be a read API, there is going to be a write API, there is going to be different APIs, which some of them are going to be read, some of them are going to be write. So load balancer, just by looking at what API call is happening, can very well figure out whether it's a read request or a write request. We will be discussing Kafka in the remaining classes, Ayushi. Let's not bring Kafka today. But rest assured, I will be discussing Kafka in the further classes. Okay, Ayushi. Yes, mapping can be there in the load balancer as well. Any question that I missed in between? Kamal says, isn't the master architecture contradictory to horizontal scaling? Kamal, do you want me to unmute you? Because I did not get what exactly you are asking. Can I unmute you, have a discussion? Sure. Yeah. Hey, Kamal.
Yeah, hi Tarun, am I audible?
Yeah, you're audible. First of all, let me clarify. Is your name Kamal or Kamal?
No, I am Hindu. It's Kamal.
Hi, Kamal. Yeah.
Anyways, so so what? So the idea of horizontal scaling was to like split the systems into many systems, right?
Okay. Right.
And
Yeah.
now, like for the
it.
master architecture, we are like, hello.
Yeah, maybe there is some lag, Kamal. Please go on. I will listen to your query and then answer.
Oh, okay. So the idea was to like split the job into many workers, and then now we are going in a reverse direction, thinking that we will like appoint one master which will take care of all these. So
Okay.
in that way, like I was thinking, like why would someone again depend on the one system after having a load balancer?
Makes sense. So maybe there was some confusion. Let me just clarify that. So let's say this is a load balancer. Okay. Now I said that these are app servers. Now instead of every one of them just being a single app server, they can become an entity in themselves. So let's say this app server is a master app server, and then you have, let's call it master one. Then you can call it slave one ka first slave, master one ka second slave, master one ka third slave, let's say. Similarly, this happens to be master 2. So slave of the second master ka first slave, second master ka second slave, and second master ka third slave, and so on and so forth. So does it now make sense, Kamal? Kamal, did you? Okay. I have unmuted you, I guess. Yes. Yeah, Kamal.
So what you are trying to do is like kind of in a school making monitors to every class, right?
Makes sense. Right.
Okay.
So
Okay.
now the maybe you guys are not able to appreciate at this point in time that why I am talking about master slave architecture. That's totally fine. Let's just wait for some time, a couple of more classes. We would discuss this again, and then you would be able to appreciate that what is the requirement of this, right? I just discussed that because some of you just mentioned something about master slave. That's why I discussed that, right? But we're going to discuss that, why this is important, what purpose it solves in the classes going forward. So don't worry about it. Okay.
I see. I see.
Okay. Thank you. Okay. Any other question that I left? Will it depend on read-write ratio? Exactly. Exactly, Sankalp. So many things in our system design classes are going to depend on how many reads you are getting, how many writes you're getting. What is the ratio between read and write request? This is a very, very important concept, Sankalp, a very, very important parameter which will define our design choices for us. Okay. Cool. Can we move ahead, guys? Can we move ahead? Did I miss any important question? Okay, pull versus push mechanism of heartbeats. Sure. So pull versus push is a mechanism which is not only limited to heartbeats. It is, you are going to see that maybe at several locations. But let's come back to to heartbeat and discuss the difference between pull versus push. Okay. So ideally, in most of the systems that I have seen, it happens to be a push heartbeat. That is, the boxes that you have send a heartbeat to the load balancer telling them that, hey man, I am alive. Okay. So generally it's a push heartbeat in most of the systems that I've seen. When I have seen pull heartbeats, I have seen pull heartbeats when I have seen multiple load balancers. So let's say you have multiple load balancers. Okay. So you have load balancer 1, load balancer 2. Let's say just in the case of Google. So you're going to have different gateway boxes, different load balancers. Now you're going to have so many app servers as well. Now, if all these app servers need to tell every load balancer that, hey, I am alive, the number of requests actually becomes so large. So everybody at a fixed interval of time is going to send a request to everybody telling them that, hey man, I am alive. Does that make sense? People, does it make sense? If you do push notification, push heartbeats here, you are going to see lots of requests going around, right? In these kind of cases, you can actually see a pull notification. What does that solve for us? So every load balancer is going to maintain कि अच्छा यार, I have asked this box in the last 10 minutes once that he was alive, or let's say in the last 2 minutes once that he was alive. Now I do not, and I am not sending any request to him. Whenever I send a request to a particular box, before I send that, I will just check myself. The load balancer will just check that what is the last time I heard from him. And if the last time was very long back, then maybe the load balancer will first make a call to it and see, hey man, are you alive? In the meanwhile, maybe send that request to somebody else. And once that request comes, response comes back, and then maybe he can say that, yes, this server is still live, I can send request to him. Does it make sense? So maybe just to reduce the number of network calls, you can actually come up with a pull heartbeat mechanism in some very specific cases. But you should know a difference between pull versus push as at a broad conceptual level, which is not only limited to heartbeats. You can have that anywhere, that a push mechanism versus a pull mechanism. Does that make sense, people? Any more doubt here? I hope not. Okay. So how many of you are feeling totally bored today? How many of you are feeling yeah, we are bored? सोना चाहिए अब नींद आ रही है. How many of you are feeling bored? Moez is not feeling bored at all. That's great, Moez, but maybe you are the only one. Okay, so there are 4, 5 people who are saying that they are not bored. So many of you are saying bored. Okay. Sukanya says that she is neutral. She is not bored. She is neither very interested in the class. She is saying that she is neutral. Okay. Swapnil is a little bit bored. Okay. So we will try to ensure that from the next class onwards, you guys do not get bored. Maybe this is because this is the first class and I am also seeing you guys after a long time. Maybe that's why some of you are finding it a bit boring. In the next classes, you should not be finding it boring. Cool. Shubham is enjoying. That's great to know. Cool. Okay. Vijay, 8:30, starting the class at 8:30 will not be possible, but we can for sure try to make sure that the class starts at 9 and not at 9:45 as it started today. I'm sorry for that. Cool. So we have discussed this. Why did we discuss that? We discussed this because we wanted to appreciate that even in a case of a stateless system, you can have the problem of a box going down. So even if it's a stateless system, and if a box goes down, my load balancer should know that this box is down and it cannot solve any request for me. Okay, so that is one advantage of heartbeats. Another advantage is that maybe let's take the example of DirectEye once again. So DirectEye, the business that I was working was a ad serving business, ed tech company. Okay, so there, on the days of Good Friday, or maybe in the week of Good Friday, what actually happens? There is a big sale in the US. Oh, sorry, that's actually called Black Friday. So whenever that season of sales comes around, the number of requests to our systems increases many folds. Okay, so we see a seasonality increase in our requests. Let's take example in India. Whenever the Amazon Prime Day happens, or what Big Billion Day happens, I don't remember that's for Amazon or Flipkart. Whether the Big Billion Day happens, the number of requests that those systems would be handling would increase many folds. Okay, this is called as a seasonality increase in requests. Or let's say you are talking about, let's say, Netflix, for example. So these days, just because all of us are home quarantined, there may be the request that the scale that Netflix is seeing is very large, much larger than the scale that it sees at other days. Or maybe you can have a system where the load is very high during the night time and is very less during the daytime, right? So yeah, right now it's big basket and so on and so forth. So you can actually have systems where the load is not static, will keep on changing. That is when you also have to add a lot of boxes temporarily. You will just add some boxes, remove them, keep on adding those boxes, removing those boxes based on the number of requests that you are seeing. Okay. Now when you add boxes as well, again you need a mechanism at the load balancer where you can just register your box and tell the load balancer that, hey man, this is a new box that I'm adding. You can start sending requests to this box as well. So yes, even in a stateless system, you need a mechanism at the load balancer which can register boxes and which can check which box is alive at this point in time. So this is a mechanism that is required at the load balancer. Now let's come to a load balancer of a stateful system. The load balancer of a stateful system now has all these requirements, but one extra requirement which happens to be that I need to know which particular box can serve this request. Does it make sense, people? So one extra requirement for a load balancer of a stateful system, as if which particular box is going to serve this particular request. To solve that, there are people actually propose different ways, but there is a very interesting way which is called as consistent hashing, and that is the best way around. I will discuss that consistent hashing, but before that, do you guys have any solution as to how to solve this problem? That how does the load balancer know that which particular box is going to be able to solve which request? Do you guys have any solution apart from consistent hashing? Okay. Nishan says session IDs. Sukanya says lookups. Shikhar says store in the browser cache. That's strange. Store in the browser cache. Are you saying that store in the client's cache, Shikhar? Okay. So Shikhar, the client should not have any detail about what happens inside the magic box, right? If I am a client, if I am a mobile app, I need not know what happens beyond that load balancer. That is the job of the server, not my job, right? So having a mapping at the client makes no sense at all, right? No, Shikhar, that's not the responsibility of the client. That's my major point. Client's responsibility does not include to know anything about what happens beyond the load balancer ka gate. Okay, Shikhar? Cool. Now, some of you, so basically, if I just, Moez is saying using some kind of history, that will tell the type of request that a particular app server has handled so far. Moez, it's not only about the type of request, it's also about what is the user ID that maybe I'm serving that request for, right, Moez? So based on the request, specific request that is coming. So let's say if data is required for you, you will actually only go to this box, let's say. And if the data is required for me, I will only go to this box, and so on and so forth. So yeah, so if I can broadly classify the approaches that you guys are giving, I can broadly classify those approaches into two different ways. Some of you are basically saying that let's have a mapping. Is that right? Some of you are saying just have a mapping on load balancer. That is, this particular user ID can be solved by this particular server ID. How many of you are saying this? That let's have a mapping to user ID and server ID. Archit is saying slightly better thing. Archit is saying that let's not only have a mapping from user ID to server ID, but let's have a mapping to user ID ki range. So user ID 100 to 200 will sit in box 1. User ID 201 to 300 will sit in box 2, and so on and so forth. We'll come to that. But let's first of all look at this. What is the problem of this problem? This kind of a solution. That is, you are having a mapping on the load balancer which maps every user to a server ID. What is the problem? The problem is that this map will become so large, right? As your users grow, you're going to have add a new entry in the map with every new user that grows. Okay? And the problem with that is that if, and also appreciate that this entire map can only sit in the main memory of the load balancer. It cannot sit in some external secondary storage. Does it make sense? Why? Because load balancer is a system whose job is to respond very, very quickly and forward your request very, very quickly to the correct point. Does it make sense? Load balancer cannot afford to actually make a hop to its DB and check ki acha yaar, what is the map, and then respond back. How many of you get it? For the load balancer, this entire map has to be there in the main memory all the times. Anybody who is not clear with this? You cannot have this map anyway but in the main memory. So that is why you cannot, this is not a valid solution, because load balancer is just one box and it is going to be having, it's going to be a box with some memory, and you cannot have a very, very heavy table which sits always on that box. Does that make sense to everybody? Just एक बार reply कर दो फिर आगे बढ़ते हैं. I hope it makes sense to everybody, right? Cool. The second approach that some of you are telling, that you can have user IDs ka groupings and say ki, and map them to boxes. The problem with that would be, first of all, as Uzair is pointing out, you can have unequal distribution. That maybe you can say that the number of user IDs in this box happen to be so most of them are filled, but in this cluster only some of them are filled. So you're going to have unequal above. Secondly, let's say you keep on adding users. If you keep on adding users, you will also have to add more such entries. Does it make sense, people? Does it make sense? This is a solution which is a bad solution for three reasons essentially. Point one, you can have unequal distributions. Point two, that you will have, you need to keep on adding entries or removing entries from this mapping. Point three, that you have lost the possibility, you have lost the option of customizing that what data sits together. What do you mean by that? I mean by that by saying that, let's say I am a person sitting in India. Okay? Let's say I am on a social network which by definition has this property that people in India will mostly be connected to people in India. Okay? Now, do you agree that for all the people of India, they should ideally be located in one group of boxes and should not be located throughout the world? Does it make sense? There should be some locality to that data. Why is that? Because if all of us are friends and we happen to be in similar boxes or boxes which are a subset of the entire box set, then the joins that are going to happen, the cross data transfer that is going to happen will be a lot faster. Versus if you just split them randomly based on user IDs to the entire world, that would be very, very bad. So the moment you come with this approach, you lose the possibility of data locality. Does that make some sense? But the primary, maybe that issue can also be boiled down to the fact that this is a static mapping that you are creating, and new user IDs cannot be added very simply. User IDs cannot be deleted very simply, and the box distribution, load distribution is not going to be equal. How many of you appreciate this? That why this solution is not a good solution? Cool. The third solution that that you guys have actually come up with is that you can have a function like a modulo function, okay? Or as Uzair is saying, as a randomized hash function, okay? So let's look at the modulo function. So let's say I have 10 servers, and whatever user ID comes, I will just take the modulo with 10, and whatever answer I get, I will say that this user ID sits on this box. Does it make sense? So let's say I have a load balancer. I have, let's say, 10 boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now if a user ID 7 comes, I will just take a modulo with 10. It will give me 7. So I will go to the 7th box. Let's say now 107 comes. I will just take modulo 10. Will again go to the 7th box. 1, 2, 5, 4 comes. Take modulo with 10. Will go to the 4th box. How many of you get it? How many of you get it? Problem of unequal distribution of load still exists. Right. Now let's actually shed light to the elephant in the room. Let's actually look at the actual elephant in the room, that what is the biggest problem that we have in all the solutions that we discuss. What happens when you add or delete a box? What is meant by deleting a box? Deleting a box means that that box went down and you cannot actually talk to that box. Or add box, that is a very, very seasonal event is happening. I need to add boxes, so I need to add one box. If any one of these things happens, addition or deletion of boxes, then you will have to redistribute everything. How many of you understand it? So let's look at the last example that I just did. So if I want to add one box, then my modulo function will no longer be modulo 10, will become modulo 11. Does it make sense? And the moment my modulo functions become modulo 11, every data point, in fact 99% of the data points are going to change. Does it make sense? So you are now going to have to shut down your service and will have to move data across these boxes. Does it make sense? And that will take some good amount of time. Let's say Facebook does that every time it wants to add a box. And let me tell you, boxes are added almost all the time. So maybe if you go to interview bit, you will keep on seeing that, yes, we keep on scaling up, we keep on scaling down, and it's an auto scale mode. It will automatically look at the load and will automatically add box, automatically look at the load, delete the box, and so on and so forth. It's always in an auto scale mode. Boxes are always being added or always being removed. If you take a downtime for every time a box is added or removed, your system is going to be unavailable all the time. Does that make sense, people? And do you appreciate that why these kind of solutions would require you to take your system down? Because almost all the data will have to be moved. So these are very, very bad solutions. These solutions should make you very, very angry. If you propose this solution to your manager, he should be very angry if he understands this anyhow. Okay. So this is a very, very bad solution. This solution is bad. The above solution was bad. And let's say a new box comes. So how will you do? So let's say a new box is coming. Abhi tak I only had mappings till box 10. Now I have a new box 11 and I would want to give it equal amount of user IDs, right? So I will have to change this entire thing, create a new map, and not only create a new map, but also transfer all the data across the boxes. Again, a very very bad solution. Okay. Right. So all these solutions are very bad. That is why we use the solution of consistent hashing. How many of you remember consistent hashing? How many of you remembers vaguely? Lokesh remembers it little bit. Sharding. नहीं यार, sharding तो अलग होता है. Okay, Deepika says she remembers it. Sukanya remembers it. That's great. Cool. So, do you guys want me to cover consistent hashing today, or do you want me to cover in 15-20 minutes in the next class? Are you guys too tired today? Tomorrow, please. Okay. I thought I will have to actually take a poll, but the result is clear right away. Dinner is waiting, right? Cool. So have dinner, Moise, and yeah, see you guys tomorrow, right? Okay. Can we have a class a bit early? We will start the class exactly at 9, Sankalp. Would not be able to start a bit early. That would be very difficult for me. Okay. So let me just take, okay, Sukanya, I have read your comment. Before you guys go, let me just take a couple of more minutes. So how many of Sukanya is saying that she found the class a bit fast, but she got the concept? So first of all, how many of you get the concepts that we discussed today? You got these concepts, right? Anybody who's feeling lost out? Nobody should be feeling lost out, right? We'll have to watch again for sure. And in fact, today's class is a little less important to rewatch because we did not cover a lot of things. But going forward, I would request you to revisit each and every class, not only once, but more than once, because revisiting these classes are going to be very, very important. And I can guarantee you that if you just revisit these classes and attend these classes, I can guarantee you that your high level design interview is going to go very well. And I have data to back that. For the previous batches that I have taught high level design, I have seen so many people who are now placed at SD2 in Amazon, in Microsoft, and they really found the classes helpful. And I'm going to assure you that the moment you take this entire module, you will be able to clear HLD rounds for very good companies for SD2 roles. Okay? So just tag along and ensure that you revisit the classes, and that would be it. How many of you would want me to slow down the class? From tomorrow onwards? No, right? A little bit slow down. Me, please. Fast. No. A little. No. Okay. How many of you would want me to speed up the class? Yes. No. Oh, cool. So almost everybody is saying not to speed up the class. Almost everybody is saying not to slow down the class. So what the inference that I can draw is that the class speed was exactly the fine. But if that's not the correct inference, then the other option, if I look at the mutually exhaustive cases, the other option could be that you guys don't know how to answer a yes and you guys always say a no. So these are the only two mutually exhaustive options. So cool. So I will look at the Typeform responses that I get today, look at how you guys rate the speed of the session, and based on that I will either speed it up or speed it down. So fill that very, very nicely. If you feel that the class was exactly at the right pace, maybe give it 3 or 4 at the class speed rating. Okay. Can you suggest any resources for these topics? That is a question that I have seen several of you asking. So I would advise you to stay away from the resources for now. Go through all the classes, and once all the classes are over, Sanket, then maybe you can start looking at some other resources. The problem with online resources is that I find is that those are good resources, but for a beginner, those are very bad resources, because those will give you wrong impressions and you will learn things the wrong way, and you will never be able to unlearn it and learn it the correct way. Okay, Sanket? Because those are basically some small snippets of information. If you just look at several snippets of information and try to use your mind and draw some conclusions, most likely you will be going in a wrong direction. So I would request you guys not to look at online resources for now. Go through the classes once. Once you have gone through the classes, understood it completely, then you can start looking at some other resources and understanding things. Okay. Does it make sense, people? Right. So Uzair is saying something. Uzair is saying, as we had this class earlier, it was easier to grasp today's concept. Not sure whether the speed would be perfect. Maybe in the next class we can figure that out. Makes sense. Makes sense, Uzair. We will figure out. We will keep on adjusting the speed. That's not an issue. Cool. Yeah. So thanks a lot, everybody. I think we can end the lecture. Would you want me to? It was very new. That's great to know, Parul. I am really. I understand that, Sankal. I understand that. Give me a couple of more days. We will manage the speed better in the coming days. Thanks a lot, everybody. I really enjoyed teaching. I hope you guys also enjoyed it. And just one request. So the central government has announced 21-day lockdown. I would request personally, I would request each one of you to ensure that that lockdown is maintained. You guys do not step out of your houses without any reason. Stay safe and stay safe yourself, and help the community also to emerge out of this crisis as soon as possible. We in India as a country would not be able to, if God forbid this goes out of hand, we will not be able to tackle it. So this is the best way that we have to fight it, and just hope for the best and do not step out of your houses. Stay safe, and yeah, just follow whatever the instructions government is giving us. Okay, thanks a lot. Yeah, thank you, Sanket. I would also stay safe. Bye. See you again tomorrow. Thanks a lot, everybody. I hope you guys enjoyed the class. Yeah. Thank you. Thank you, Suganya. Good night. Good night, everybody. Bye.